Hi, good evening. Welcome. My name is Kisik Kim. I'm an Android engineer from iHeartRadio. So this year, I went to FA conference and get to have a chance to learning Litho. I thought it was a very amazing framework, and I'd like to share what are the benefits, the benchmark test result we had, and going over some of the basic fundamental, the how to use it for your app. So what is Litho? So Litho allows you to write highly optimized Android views through a simple functional API based on Java annotation. It's primarily built to implement complex scrollable UI based on RecyclerView. So this is one of our sample code how Litho the code look like. So let's talk about the Android UI development. So most common UI pattern we see is a list type of views, scrolling either left to right or top to bottom or bottom to top. And a common solution that Android Space offers is RecyclerView. I'm pretty sure most of you use the RecyclerView for your app. iHeartRadio also uses RecyclerView for our listing our live stations or artists or songs or podcasts. So before we talk about Litho, let's talk about Android RecyclerView and what are the problem that we had. So building a list interface in Android is fairly simple. Just create a layout for items, list item, and hook it up to RecyclerView Adapter, and you're good. But most application is a little bit more complicated than that. Sorry. So the PinPoint. So when you have too many views type, RecyclerView will be constantly inflating new views every time because you have a lot of views types, and which means it will likely cause frame drops while scrolling. If the list item gets complex, chances are you will have to optimize your layout. So common approach that is implementing custom views that will use use cases. However, custom views can be great for UI efficiency, but it's tend to slow and it's adding a lot of complexity and it's higher maintenance costs. So what can we do to solve our pain point? The solution is from Facebook. They have Litho to improve your scrolling performance by 35% on mobile app. It's easy to code for you the complex UI feature. It has smaller memory footprint. It has better test coverages, which means it will increase your user engagement for your app. So let's talk about how can Litho help. So they have three strengths. First is measure and layout in background thread. Second is automatic view flattening. Third is smart incremental recycler. So let's talk about what they mean. Measure and layout in background thread. Okay, so let's look at the RecyclerView model. A RecyclerView model, Android, they perform measure, layout, draw, running main thread, which takes up the rendering time. And if you use your Android API, there's nothing that you can do fight against it. However, Litho approach is different. They take out measure, layout operation in background thread, and only perform draw operation in main thread, which means you will have more chance to render one frame per within 60 milliseconds. So what I mean is rendering 60 milliseconds is most Android devices out there supports 60 frame per second. That means we have to draw within 16 milliseconds in order to render smooth. And that's not really easy. But because Litho was able to take out measure and layout operation from the main thread, it gives more free time to render in the main thread, which means more smooth rendering. View flattening. This is the part that I really like, by the way. So let's look at the one of our sample here. So you have a top row with a row container, and there's a rectangle on the left corner, and there's a hello world, this is my title, and there's my subtitle at the bottom. So typically when you have a feature request by your product manager, can you build this the list item here? Then you can probably start with the relative layout and draw a container for which is your relative layout, and you start drawing a rectangle, and you draw a text view with a hello world, and you have another text view with the maybe potentially contain linear layout with a vertical layout, or if you're more experienced, you can just relative layout and have a relation. But as hard as you can do, Android will see as 4 views on their system, which is container, rectangle, and 2 text view. However, in Litho, once you program how to create view, and under the hood, they create new view out of your component, and they make a one view, which will be same exact the view that the user will see. So difference is that user will see the same view as a rectangle, hello world, and this is my title and this is my subtitle. But system will think that, hey, I'm just seeing as a one view object, and this is a really great feature, by the way, because in Android, view object is very heavy. If you have a lot of views on your app, likely you're gonna have a Stack Overflow errors, which means you have too many views. And this can be very problematic, that we are supporting million devices out there, and normally the high-end devices that any devices comes out every year shouldn't have any problem. But if you're supporting low-end devices, or I don't want to mark Amazon devices, but the Fire devices, they usually give a problem with a lot of views. And Litho can help you. Smart incremental recycler. So what does this mean? So I have a video slide next. So in RecyclerView Adapter, the way that they recycle each list item, they see as a one view, and they hold it in memory. And every time that system knows that it needs to reuse it, it will just keep using as a one container. But when you have a lot of view types, this can be preserving a lot of memories in the back. So what Litho offer is every view container is at the end, it's a composition of the either image view or text view or 360 views or any drawable that you can think of. So they only pick up the core component, which is like images, video, and text, and figure out which needs to be recycled really matters, and use less memory that way. So I'll just demonstrate the video that how RecyclerView Adapter would. Oops, sorry. So this is a RecyclerView Adapter, how they perform the recycle, and I'll show you Litho. So next, we had a performance test, Litho versus RecyclerView, and I'd like to introduce Lee Fan, who's our Android engineer in iHeartRadio.
Good evening, everyone. Welcome to iHeart. My name is Lee. I'm from Android team. So we did some simple tests on view flattening using both RecyclerView and Litho. And the result is pretty impressive. But before we get into the results, just in case anyone is not familiar with how Android View framework works, so think the Android View as if you are making a collage, which is a piece of art made by staking stuff like photos, pictures, papers on top of a backing. Say you get a white paper and you start putting on pictures, photos, and you cutting paper into shape and you put on top of it. And then finally you got picture. So now think the Android view as a collage. So the picture, each picture you put onto the collage is the view's child view. So the more picture you use, the more child view the view has. That means the more system resource it's gonna consume. And how does Litho help? So Litho takes the collage to the printer and then print it out. Now you get a copy that with exactly the same looking, but the difference is it just costs one paper. So what we did in the testing is, so we built two exactly same view using RecyclerView and Litho. And then we use some third-party library to display the view in a 3D vision. So every single child view can float up. So you can clearly see there on the left side, the RecyclerView has lots of layers. But on the right side, on Litho, there's each view cell only contains one single view, which is very good. For the footprint, it's very good too. So the overall footprint for the RecyclerView you see on previous page is like 100,000. And if you use LithoView, the footprint is cut almost by half. Yeah, that's it. I'm gonna give back to Kisik. Thank you.
Thank you. So now that we know that what are the strengths of Litho, let's take a look at the key Litho's component in the programming model. First is the prop. So prop is the immutable input in Litho. So if you see function static component layout on create layout, and you pass in component context, which is the Litho's context, specialized context, and you need to see to prop int color and prop string title. So in Litho's programming model, you pass with a prop value that you want to pass in your input, your functional programming model. And your output model will be eventually view. And the prop is think of it as the immutable input model always. So as you can see the graphic, your input will go down to one way the directional, and you can create any views that you want. Layout spec. So Lithos, they have a function called the layout spec. So layout spec is it generates the think of it as a new view group on Android. Layout spec class has a function called onCreateLayout. Just like our previous slide, we pass the component context with depends on whatever you want to pass. Like currently, I'm passing color and title, and you start returning with using common build pattern. We start with a row containing child, which is your solid color block, and you can set up the color that you're passing to, and you can also specify the text value you want to pass it to. And this is the example of the usage layout spec. So once you have a view created, I have a recycler binder which I'll go over in next slide. So recycler binder, which is equivalent to RecyclerView Adapter, and you can insert item that component that you created from the Litho. So I have a list item that create color, passing color value and title, which is here, a prop value, prop color and title. And you can pass that as like this. So with a using build pattern that create context, which is and Litho context, passing color value, and passing the title, and you build it. And once you build a component, which is your Android view group, and you can insert item, the recycler binder. Recycler. So Litho has a recycler. It's equivalent to RecyclerView in Android. So it's the same as the other component context that they have. So you pass the component context, and you just return simple recycler, and you just make sure that it binds with the recycler binder, whatever you want to pass it to. Recycler binder. Recycler binder is logically similar as the RecyclerView Adapter. So you create recycler binder with the layout info. It could be gray layout or linear layout, depends on what the product demands are, and you build it. And the recycler binder programming model is you can insert or remove or update, passing the position and passing the component, which is your view group that you just created from the Litho. Recycler binder is easier to use than RecyclerView Adapter. So let's take a look at RecyclerView Adapter sample code. So RecyclerView Adapter has functionality called onCreate view holder and unbind view holders. So we all familiar with this. OnCreate view holder will be the first time they're inflating the view if it is created first time. Unbind view holder which means if it needs to be recycled, and you're passing the data that it needs to be positioned, and you get the position of the data, and you update the view for the data. And if you're not the Android developer, if you see it the first time, then it's a little confusing. What this means onCreate view holder and unbind view holder. Litho has programming model like this, which I went over in previous slide. So you have a recycler binder, which is similar as a Java collection. So you can add, insert specific position, or remove, and you can update the view without thinking about how to manage the adapter. Depends on how many views that you have. So now that we went over Litho's basic component, let's build this simple UI. So if we start with the traditional Android way, you start with the relative layout, start building image view, which is the iHeart logo on the left, and you have text view, and you will have a text view on the bottom, and you have another image view at the right corner with XML. Then you have to create your RecyclerView adapter and think about how to apply the data, the view that you created. In Litho, we don't have to create the XML. So they offer functional programming model. So just like the layout spec classes, you have a function on create layout, pass the value that needs to be updated for the view, and you start with let's start with this build, the row. So you have a row container, which is one list item, and you can specify padding for the row. You can set up the background color, and you have a child. So your first child will be your images, which is the iHeart logo at the left. And you can specify which drawable resources you're gonna use with the layout, how many, the height or the sizes that you need to specify. And you can have another child in the left, which will be column. So column will be holding the vertical, think of it as a linear vertical layout. And we'll have another child inside text, which is hello world, and have a child, another Litho tutorial. And you're gonna have, and closing the column, and you can have another child, which will be the button, smaller text on the right. In your main activity, you'll have to start with same called super down create, and you have to create component context, which is the Litho specialized context, which will be equivalent to your Android activity context. And you create recycler binder, and you create the recycler, which is RecyclerView. And at the end, you have to call set content view, which is the Android API that draw the main activity, and you just pass the Litho view create context and component. So you create the recycler view at this moment right now, but it will be empty. So in order to fill in the view, you can have another function like just add content. So this can be called typically when you fetch from your backend or databases. Once you have the information ready, you run some sort of a for loop. And per data sets, you updated them. And now since this model is very dynamic, so you can have tons of multiple data and tons of different views that not worrying about how to manage adapter. You just need to specify which position that you want to user to see. So my own thoughts on result is very good. It's very good for complex list type. View flattening optimization will make our life very easy. If you fan of functional programming model with an unidirectional data flow tend to be much easy to reason with even if the product gets more complex. So it's very easy to, which will be also easy to test as well. Weakness. So per Facebook, very dynamic UI with the animation. Gesture currently hard to implement Litho right now. So it's coming, but not currently supported right now. Is iHeartRadio considering using Litho? So we are using RecyclerView and RecyclerView Adapter right now. But in next quarter, we are thinking about backend driven UI configuration runtime changes. So when backend gives some sort of instruction like a JSON response and per the JSON response, and then I think this programming model makes it much easier to draw to build your application rather than relying on the XML. So I have a funny picture. If you're struggling with building complex UI, gives your rendering trouble and not scrolling smoothly, then try Litho. This is it. Thank you. And I'll take any questions that you guys may have.
Can you edit like properties of the components once you've added them to the binder? Like if you want to change the text?
Yes. So they offer insert item. So during runtime, you can just change it dynamically.
You would remove what's
Yep.
there and insert
Yep.
again?
Yep.
Is there something similar to like diff utils for Litho?
Yes. I'm not really 100% with the diff util, but there's a diff util offered in the Facebook, the Litho library. So there's a way. Yep.
You had a
slide up there where you originally started with XML and you went into Litho, where you create the view itself in code.
Yep.
Is there any way to go back to just use XML? Because it seems like a lot of code you have to put in to create a more sophisticated view within the RecyclerView.
So the question was this programming model is a little bit more complicated than the print the XML. Did I get the question right?
Basically, yeah. So
Right.
I was wondering if
So-
Litho would allow me to still use the XML.
So one of the strengths of Litho is they really focused on how to simplify the building UI. Android XML, if you not really expert at building XML, you can have tons of attribute, and it can look like a garbage at the end. Every time Google has new update, XML gets more complicated. Then when your teammate look at your code and, hey dude, what is this? And this is like, I don't remember what we're doing. So that was the point that actually Litho point out. So this programming model, you may think it is actually this is a lot of work, but it's really, to me, it's easier to read than reading the XML. So this is the most the strengths that they talked about. You don't have to be a fan of this, but if you like the build pattern and functional programming model, I think you may prefer over the XML.
It's related to the previous question. Aren't you using some attributes that are used in styling and theming?
Yes. So because the Litho actually running on the Android at the end, so you can use the example would be drawable resources here. So you can have drawable resources that which is using Android's resources, and so it's very compatible with each other. I think the style and the theme, I'm not too sure. I have not seen it, but any that basic function like a dimension or drawable resources or string resources, they are easily work with. Mm.
What about constraint layouts? Have you had any issues with those? With some of the more complex things that it does, like default width for text and matching parent at the same time?
So question was if you use a constraint layout, which is Android constraint layout, this one, right?
Yeah.
And what's the next part? I didn't get the.
Basically, it was just a complex. Have you used constraint layout, and have you used it with some of the more complex things that it can do with Litho?
Right. So I have used constraint layout. I didn't have a really great experience with it. So per Google, constraint layout is their current solution that most optimized views that you can get from the XML. The one of the strong advantage that over constraint layout or XML would be you can actually see the view, what the will look like before you run the app. Litho, however, you cannot really see what the output until you run the app. So that's the difference I see. I really hopefully constraint layout will step up better, but in my personal experiences, I didn't have much luck.
How do you handle different view types?
How do you handle? So the question is how do you handle view types? So I think this is where you can actually take advantage of Litho programming model. So because handling different view type in adapter is not really easy because you have to deal with these types of code here that you know how to manage this, how to recycle once you have adapter. But when you have a Litho programming model, when you have a different view type, then you can just simply say, hey, I'm a type data A, and I need to view type A because I'm type A, and you can simply just start inserting them without worrying about the adapter. I hope this answers your question. Where is it? Some questions. Yeah, okay. Does that help? Okay. Okay. I think this is it. Thank you very much.